Hello everyone, I am Dr. Shantala D. Patil, Assistant Professor, Government First Grade College, Anand. Our college is affiliated to Gulbarga University, Kalburgi. Today we are going to discuss on the second law of thermodynamics. We have discussed in the previous class about the first law of thermodynamics, and it is a conservation of energy adapted for the thermodynamics processes. And also it defines two forms of energy, that is heat transfer and the thermodynamic work. Also we have discussed the internal energy of a given system which cannot be measured. Since it is not possible to estimate all the components, we thus consider that only the change in the internal energy. We are going to discuss this topic to understand the limitations and the conditions for the interconversion of both heat and work, and also to understand the concept of entropy. After this discussion, you should be able to state the second law of thermodynamics and disorderliness of the system, that is entropy, and also to calculate entropy of the system. The second law of thermodynamics identifies the direction of a process, that is, heat can only spontaneously transfer from hot object to a cold object, not vice versa. That is, not from cold to a hot object. And it is used to exclude the possibility of constructing 100% efficient heat engines and machines. It is used to introduce concept of reversible process and irreversible process. So reversible process is one in which both the system and its environment can return to exactly the states they were in by following the reverse path. But in an irreversible process, it is one in which the system and its environment cannot return together exactly the states that they were in. There is no simple statement for the second law of thermodynamics, and it has three prominent ones. Those are Clausius statement, Kelvin statement, and entropy statement. And according to the Clausius statement, it can be defined as it is impossible for any system to operate in such a way that the sole result would be an energy transfer by heat from a cooler to a hotter body. And from the Kelvin's Planck statement, it is impossible for any system to operate in a thermodynamic cycle and deliver a net amount of energy by work to its surroundings while receiving energy by heat transfer from a single thermal reservoir. And from the entropy statement, it is impossible for any system to operate in a way that entropy is destroyed. According to this law, in a theoretical and reversible heat transfer, an element of heat transfer delta Q is the product of the temperature T and with the increment ds of the system. That is, delta Q is equals to T into delta ds. So, the change in entropy ds is equals to delta Q by T, where S is entropy. That is entropy, which is a state function, and it measures the amount of disorderedness of the system, and entropy changes are always the path independent. The total entropy of an isolated system that undergoes a change cannot be decreased. And what do you mean by the isolated system here? And we discussed this in the previous class, that it is a system where energy and the matter are not going to exchange with the surroundings. If the process is irreversible, then the total entropy of the system is always increased. And in a reversible process, the total entropy of an isolated system remains constant. To summarize, second law of thermodynamics identifies the direction of thermodynamic process. It is used to introduce concepts of reversible process and irreversible process. We understand we discussed already reversible and irreversible process in the beginning. So it determines the best theoretical performance of cycles, engines and other machines. Entropy is the amount of disorder in the thermal system and it is a state function. There are very basic MCQs based on our discussions. Please go through this. Thank you.